نشكر السيدة عائشة المنصوري والسيدة خزامي الحرمي على كلمتهما. والآن مع كلمة الدكتور محمد سليم من جامعة قطر، فليتفضل.
السلام عليكم. Well, first of all, I would like to thank the scientific committee and the Qatar Engineering Society for this invitation. I am here actually presenting a paper under the title of the health sectors, engineering health sectors. I was searching for that one, and I found out this section has been allocated under a title of scientific area that's related to the healthcare and their contribution to the pollution of the environment, which is not really what we are here for. So I decided just to bring one quick slide from one of the journals from the United States, talking about how the health care can contribute to the pollution of the environment, which really was shocking for me because I didn't have previous information about it. So in this one, they were talking about like industry, as everyone knows, industry and the houses are the main contributor to the pollution. However, in this case, we'll have significant part or portions of the pollution came from the hospitals and all these care centers. As this second line, the red one, tell about what is the pollution came from the health care sectors. So they say here, like we have the impact of, that will include acid rain, 12% of the pollution came from the health sectors. About greenhouse gas emission, we have 10% and so on. The rest almost 6 parts that's related to the damage of the environment came from this healthcare. The last one, the red line also talk about the estimated almost 500,000 pay for the damage came from the healthcare sector. So this part, what it is under that section of this conference, which is not actually my main aim for my presentation. But I thought it's really interesting to know that this sector also one of the contributors to pollution, which I didn't know myself before. If you don't know, so now you can have some knowledge about it. In my case, I look at quickly a quote came from the Britain Premier Health Journal. It says, climate change, and this is the problems now we are going to face in Qatar and most of the region in the world, the changes that raise the red flag for the Ministry of Environment and municipalities this year when they create a committee and they consult and hire a consultant just to do estimation and create strategies and recommendations for the future development in Doha. And somehow I was part of that one because me as a lead of one of the grant research with the Portland State University in America, we were working on something called the Heat Island in Doha. And we were doing the technical part of it, a lot of data collection, a lot of analysis. We came with some really result. So we were supporting the municipalities with our technical, while this consulting office that's working with them, GHD, I think they called, they were more talking about theoretical issues. And both our technical and their theoretical issues create very nice report for the municipality to be considered in their recommendation for future development in Doha to take to consider the change of the heat. Here, what they say here, they say climate change is going to be the biggest global health threat of the 21st centuries. So a lot of heat, what can we do with it? Human has a problem. If you look here, I make this chart also with my team, research team. Usually when you see about temperature, we always look at hot, mild, and cold. In fact, it's not like this. There is 5 different degrees of heat. The first one, we can say cold, when it is below 18 degrees. Yeah, 18 degrees. And below. Between 18 and 24, call it comfort zone. Some people may say 25. This is okay too. Comfort zone when you don't need to have air condition, and you don't need to have extra clothes. You can sit at home very nicely. You can walk outside very nicely. This is a time of like March, April. What we have. Second, so this is 2 different zones of temperature. The third one is called hot zone, from 28 to 38, 10 degrees. So, sorry, I missed one here. Between 24 and 28, we have the warm zone. Warm zone here, it's warm. You may have fan to survive. You don't need to have an air condition, but everyone has air condition at home. They prefer to turn on their air condition for it more comfortable because they are using to do it in this way. But however, some people might prefer to use fan only to survive for this time of this kind of temperature. Sorry. Now the fourth one is a hot zone, which is from 28 to 38. Here we use air condition right away. And this one will not be a threat to our health because the heat of our body is 27 maximum or around 27. This one can tolerate and can really work and survive with up to 38 degree. However, when it's go beyond 37 or 38, we go to another zone, which is number 5, called sweltering zone. Then we got sweat. Then the body have to look at mechanisms to really reduce the heat of the body. And this is going to be the dangerous zone for everyone. From that study, actually, we decide to go to right away to create our own strategy for the research. And we had actually 3 points here. Understanding of the influence of the built form and human activities on microclimates. Why microclimates? Because we are mostly walking on the street within districts. So we have to deal with urban district, not on the city scale. City scale, because every part of the city has different urban district, and we found out every urban district has different heat, different temperature. You may have the difference between probably one district and another probably 5 degrees, 4 degrees, 2 degrees, etc. Second, understanding of the key environmental variable affecting air temperature in urban environment. What I am referring to here, the material are used. Asphalt, concrete, it's one of the things. Do you have green areas, garden, parks? You have water bodies, and so on. This is what we are really looking at different mass that form the land cover of our urban areas. From there, we can develop some studies. Here, I'm referring to the corridor. That means the street of some street in Doha. So we look at 2 streets. One of them was Selwa Road. I'm going to present it here. The other one was Arayan Road. As you see here, Doha from 2003 up to now almost, we have a lot of big change in it. This big change takes us to this one to say the land cover, we have to look at the development in terms of the cover it by vegetation and or by hard surface development and hard surface or hard mass like buildings. We can see that in 1987 to 1991, almost they were the cover of the land use, probably here when there is not much, you see, not much redevelopment yet comparing with the other. They were almost 18 kilometers square, while the vegetation was 5 kilometers square, which is the percentage almost 20% of the development were greenery at that time. Look at as we move in to the last one, 2009, 2013, we have 131 kilometer square, while the greenery only 80 meter square. And that is really scary. You can see almost we're talking about 6%, 5 to 6% greenery now development comparing with the mass production of development of the urban areas. So that means there is not much greenery or vegetation in Doha now comparing with the developed areas for urban. Actually, the study has a number of phases. As I say, I'm not going to go through all of them. But the interesting thing is now we selected 10 areas, different areas distributed all over Doha. It was a weather station to take temperature for the whole year, for 1 year. From there, we did some calculation to find out how the temperature has been distributed in the city. So we had some study, some map for the same day, September, from 8th and 9th of September. We have in the morning, in the afternoon, and in the evening. And you can see, for example, here, the maximum height 36, while here it was 29, the lowest, the blue. You can see the heat island is where it is located, almost in the downtown, where is the Museum of Islamic Art. And this is where it is like Mushayrib and Souq Waqif and Najada, etc. area. The airport also create one of the heat island and so on. When you move into the middle of the day, we can see the heat island almost less here in this area, more towards the industrial area, as you see it here. In the evening, we go back to this, almost to the, close to this coast or Corniche, there is also heat. But surprisingly, you can see this road here. This road is a Salwa road. It's always represented as a heat island within the city itself. It's called it corridor, heat island. So the study here, I will present two studies. One of the studies look at the corridor of Salwa. Another study will look at two different neighborhood districts and how we're trying to propose some improvement to reduce the heat on those neighborhoods. The Salwa Road, as you see, this is what is the location of it. Start from the shore. This is a Corniche, all the way inland. And usually this is the way it lay out, is where is the wind also blow throughout the day. Mostly the prevailing wind came from this direction, same direction. You can see the road has different land use, and this is a map of the land use, the legend of the land use. Around it, there is all type of relay activities around it. We did the traverses. The traverses, that's mean here referring to the car. We put the temperature recorder on the car, and we drive on that road, on the side road. We didn't try really to ride in the middle of the road. The interesting about this study is when you do it in traverses, that means we are trying to look at the heat that's related to the pedestrian more or less, not the car driver and the car. Why we need to do that? Because here when you're trying to see when the people walk on the streets, how they experience the temperature. So we had it 3 traverses per day. In the morning, 6 to 7. In the evening, in the afternoon, from 1 to 2. And in the evening, from 7 to 8. And we make it in 2 different days, Friday and Tuesday. Friday, when there is no business, people mostly sitting at home, wanted to see how is the temperature on the road. And Tuesday, when it is really crowded with a lot of activities, school buses, people going to work, etc. So we select a busy day and busy day. And you can see the temperature here really are different from the beginning to the end of Salwa Road. Now, this Salwa Road has been divided into segments. Every segment is 100 meters. Every segment here is 100 meters as it is. Second, what is around it? We take buildings in depth on both sides, 200 meters and 400 meters. We have to study both cases. And we look at the traffic, and we put traffic at different points, mostly in the injection point, cross road. And we counted how many cars are passing those areas. Also, we take into consideration in our study is the distance to the corniche. Distance to corniche. So it has to be straight line distance to the corniche. So the result of the study was very fascinating. Usually people think that everything close to the corniche is going to be cooler than inland. However, the study show it's not true all this time. This graphic actually shows the result. So you have to look at it. The first two here referring to Tuesday and Friday in April. While these two here look at July and August. This was the end of July, the beginning of August time. And as you move, if you imagine there is a line here between this one, so this part is April, this part is July, August. This one, when it's supposed to be the temperature to be mild, like today, the temperature, while here it's supposed to be very hot temperature. We noted that, like in the morning, was on Tuesday, we have negative. The more you are far from the shore, from the corniche, the temperature will drop down. Not the other way around, in the morning. So that means in the morning, if you wanted to have really nice, cooler area, don't go to the corniche. It's going to be hotter than inland. So the distance to coast. Traffic has also some changes. Remember, the corniche, the area we're talking about, Silver Road, is congestion, and also there is crowded with buildings. Friday has similar, almost. Friday we have as far from the, as you are moving fast from the corniche, the temperature will be less. In the midday of the same day, we can see almost there is no significant difference in temperature between the coast and the inland on the, as a result of the closer to the corniche. However, the traffic has not much difference. When you go closer to the inland, the temperature still going negative. It's not significant. Those studies are not significant. As we are saying that regardless where you are, the temperature can be the same. Here on a Friday, this is Tuesday. On a Friday, and specific in a Friday, in the afternoon, when you are closer to the corniche, the temperature could be less than inland. As you go in the evening here, the, closer to corniche, the temperature is better, while in a Friday, the temperature has negative as you move inland. So this kind of study actually tells us the temperature always changes between morning and noon and the afternoon, and the best place is not necessarily to be the corniche in our case. And the effect not necessarily to be of the building or the car, mostly the distance to the corniche is the most effective factors of the temperature on Silver Road. Let's think about Silver Road before I move to the second part of the study. Silver Road is a very wide street. So all the temperature, all the pollution coming from the car and whatever surrounding from the buildings, usually the prevailing wind will sweep it away. That's why we didn't see any significant effect. Well, if we did the same study, we have actually done that, but I didn't present it today, on Arayan Road, which has the same layout from Corniche to inland. We found different results for sure, because the width of the Arayan Road is less. Here we are talking about almost 40 meters. I think my estimation 40 meters wide is the Silver Road. 40 to 50 meters. Just a quick summary for what I say so far. found that the morning in April showed that a strong negative correlation with the distance to the coast, but trend reversed and showed a positive correlation for evening inland area warmer. Second one, some small correlation with volume at 2 p.m. and 4 p.m. in April. Surprisingly, only small correlation with the traffic volumes. So again, I'll say because really little significance for the traffic because the width of the road, and we are not really studying the middle of the road. We are studying on the almost the pedestrian side. We are caring here about the user who walk on the street. Now the other study, look at the district. We select actually 3 districts. Here I'm representing only 2 districts. One district is fully developed district, just on beginning of the Salwa Road. It's Al-Wa'ab district, approximately 66 kilometers southwest from Dawha Bay. This one, we used to call it the Mercedes roundabout, just behind it. This is the area where we have this district. And you can see this is when we did the study, the full district, and this part we put more emphasis in our study. And if you look at the material are used there, and the 3 perspective of the place, and show the sun shading on that 3 different perspective. We did some proposal for that district. We say even though it is fully developed and the temperature is very high, we have to change some parameter from that one. One of the parameter has been changed to gray paver. So any paver here, we move it from asphalt to gray paver. And the pavement for pedestrian, we found out in our study that if it has a green color, it will reduce the emission of the heat from that surface. Second, we have masonry of concrete primary wall and install the green plantering. So we have always create, instead of having a fence of concrete, we replace it with hedge to be green, also to reduce the reflection of the heat. The last one, sidewalk, also we suggest some trees to be there. The second case, this is some of the perspective of that neighborhood. You can see how it was and how we are proposing to be. It looks like with some greenery and changes of the pavement color and so on. So from the perspective, you can see it's here more livable, more inviting, comparing with the previous one. I don't know if you share me this idea, because the buildings are not very high and the distance between in the street proportionally are wide. People don't have the courage or they don't find the reason to walk on the street. They don't find this street really for walk somehow. So we put some trees. You are breaking the proportion. We make it more really acceptable, more warmy or more inviting urban areas to walk in and have some socialization. The second case is actually we took Salal when there is a district are almost less than half being developed. That means the land mostly empty and there is some buildings. This one beside there is a mall there, so Boulevard Mall, I think it's called, was under construction at that time when we did the study. I think now it's finished. And in this study, we decided to do development for the undeveloped areas to be more for encourage people to do street activities like riding bicycle, like meeting outside in a cafe or in an open area, in a small green area, etc. So we have here pedestrian-friendly street. That's what we're trying to propose. Bicycle ways, arcade, when people can walk away from the sun, courtyard and parks. So all the development of the building has to create like kind of really courtyard to create really nice microclimate. A new social medium, so create like community facilities and places to go and meet others, etc. So in the neighborhood itself, only for houses, usually it's not good enough to encourage the residents to go and walk on the streets. So we have to create kind of really commercial activities or park or recreational or something within the neighborhood. So there is a reason for people to get out of their houses and walk outside. Once they walk outside, the socialization will start there. Now, as a summary from this second case, there is actually here just emphasizing on planting future growth to ensure efficient, convenient mass transit where conditions permit walking and bicycle more. We don't need people really to be encouraged always to use a car. So there is either walking or riding their bicycle if it is possible. And also, the second point is to trying to switch away from the fossil fuels. This one, even though we wrote it in this presentation, I was in the United States, actually, in California or Portland also, and they have now a policy within 2023, I believe, or 4, the city says all car or 50% of the car has to be operated by electricity. By 2030, all the car has to be operated by electricity. There is no car operated by gas or so on. Just to make sure that the car is not going to be a source of pollution for the environment. I think Doha will follow very soon this kind of really trend, because it's kind of trend like using the cell phone. Everyone has a cell phone. In the future, everyone will have a car operated by electricity. So it's going to be by default will be solve this problem. More thing to as a responsive to this study, we have to put emphasis on the eco district and find out what is the variable that can be changed to improve the temperature in it. So the temperature usually came not only from the car or from air condition, from the material also it has albedo effect, and the color of the you are using for the building and for the pavement also has to be taken into consideration. Okay, I think that's it. We have to pay attention more to vegetation also, the last point. And thank you very much. I hope you enjoy the presentation. Thank you. Any question? No question. Thank you.